May June 2024, Paper 2, Variant 2. Question 1, Part A. Complete Table 1.1. So in this table, there are three items: nucleons number, proton number, numbers of electrons. So for the magnesium ion and the aluminium ion, okay, so first is already given the nucleon number 24, 27. Proton number you can get from the periodic table, so which is 12 for magnesium. Aluminium is 13. So the numbers of electrons is based on how many electrons that is released from the elements. So since it's given magnesium ion, means the magnesium element or the atom is released 2 electrons. So it remains 10 electrons. For the aluminium, it's released 3 electrons, also form 10 electrons. So means the magnesium ion and the aluminium ion, they are isoelectronic structure or configuration. So because same electrons numbers. Part B. State and explain the difference in the ionic radius of aluminium and the magnesium ion. First, you need to state, then explain. State means try to state the ionic radius. So we know that the ionic radius of aluminium is smaller than the magnesium ion. So this is the one that you need to state. If the statement's wrong, explanations is not going to work. So first you must make sure the statement is correct. So why the ionic radius of the aluminium ion is smaller? First, it must be because of the proton number. So we know that the proton number of the aluminium is greater than magnesium, so which is 13. So therefore, first you need to explain aluminium ion has a greater nuclear charge. So because the nuclear charge is based on the proton number, so it's the ones that attracts the electrons. So first you need to mention this one, greater nuclear charge. After that, you need to of course, because it's isoelectronic configuration, so you can say that it's the same shielding effects. Same shielding, right? Because the numbers of electrons same. They have the 2 electron shells and the electrons also same, right? So we say that aluminium ion has greater nuclear charge and at the same time same shielding effects compared to the magnesium ion. Therefore, the aluminium ion has a greater nuclear attractions for the remaining electrons, or for these 10 electrons. So first you need to understand the difference between the nuclear charge and the attraction. It's because of the greater nuclear charge, the nuclear attraction is stronger. So it's different things. So you need to make it clear. Because of greater charge, then the nuclear attraction is stronger. Okay, part C. Draw a label diagram to show the bonding in sodium. Okay, very easy. Normally you need to draw at least 6 particles. So if you can draw something like this, is enough. So you need to draw the this sodium ion. You just put a positive, okay, with the circle, right? So you just draw a few of that and label that sodium ion, and you put the negative charge surrounding these ions and label this negative as delocalized electrons. Okay, part D. Figure 1.1 shows the variation in melting point of some period 3 elements in their standard state at room temperature and pressure. So this one is later part 2, you need to complete that. Complete figure 1.1 to show the variation in melting point. Let's discuss this one, then we go to the part 1. For the melting point, because it's already given this part, from sodium to magnesium increases, from magnesium to aluminium also increases, but it's a smaller increase. From aluminium to silicon is a larger increase. Okay, from this part onwards, from silicon, you need to draw or complete the melting point track. Okay, first you need to draw the drastic decrease from silicon to phosphorus. Make sure the melting point of phosphorus is lower than the sodium here. That's the first thing you need to do. After that, from the phosphorus to sulfur, you need to draw another line, increases. Make sure the melting point of the sodium and sulfur is comparable. They are quite close. So you can just draw one line up. Okay, make sure it stay similar to the sodium. Okay, after that, from the sulfur to chlorine, so you need to draw this melting point decreases. Make sure the melting point of the chlorine is lower than the phosphorus, or lower than all of these elements. Okay, first, why the phosphorus is lower melting point than sulfur? Because the phosphorus is the simple molecular structure is P4. So 4 phosphorus atom in the molecule. Sulfur is S8. In one molecule, there are 8 sulfur atoms. So therefore, the sulfur size is larger than the phosphorus. So when this size is larger, then the ID forces means the intermolecular force is stronger. So the melting point is higher. For the chlorine, because it's Cl2, right? So it's just 2 atoms in one molecule. Therefore, it has the lowest melting point compared to the others. So this is a trend that you need to complete. Okay, let's back to the part 1. Explain why silicon has the high melting point. Okay, as shown in this figure 1.1. Why silicon has the highest melting point? Very easy, because silicon its structure is similar to the carbon. If you remember, the carbon, there are 2 allotropes. One is the diamond, another one is a graphite. So the silicon structure, most likely it will be like diamond, tetrahedral geometry. So therefore, we know that silicon has a giant molecular structure. So because in order to explain the melting point, you must explain the structure. So because the silicon has giant structure, and this giant structure is molecular structure, and large amount of energy required to break the covalent bonds in this structure. That's why it has a high melting point. Okay, part E1. Complete table 1.2. So for this table 1.2, there are 3 columns. So the first one is the elements, sodium and sulfur. Second, state of oxide at room temperature and pressure. Sodium oxide most likely is the Na2O, so it's a solid at the room temperature and pressure. For the oxide of sulfur, most likely is sulfur dioxide or sulfur trioxide, and these 2, they are gases, right? So it's gas. And the pH of solution make when this oxide add to water. Sodium oxide add to water form sodium hydroxide. So the pH is around 14. Sulfur dioxide, when it dissolves in water, it will form sulfonic acid, H2SO3. Sulfur trioxide, when it dissolves in or reacts with water, so it will form the H2SO4. So the pH is very low. You can put 1 or 2. So it's better just put 2. Okay, part 2. The solutions made in the column 3 in this table 1.2, they are mixed together. Name the type of reactions that occur. So the solutions that produce, this one is the alkalines. So this is alkaline because of the sodium hydroxide that produced. And this sulfur oxide, it will form the acid solution. So it's better for you to say acid-base reaction. The type of reaction is acid-base. Of course, you can say, or you can put neutralization, but it's acid-base is better. Part 3. Write an equations to describe the reactions between the P4O10 and the water. So very easy. Phosphorus oxide reacts with water, only form one acid. It's formed the phosphoric acid, H3PO4. You just balance it. Okay, that's the equation. Part F. Aluminium hydroxide is amphoteric. This question is a bit special because it's not aluminium oxide, it's aluminium hydroxide. Now, part 1. Explain what it means by amphoteric. This one is very easy. You just need to mention this one. The substance that reacts with both acids and base. As long as the substance can react with both of these, so we call this substance as amphoteric compound. Part 2. Write an equation to describe the reactions that occur when the the aluminum hydroxide reacts with the sodium hydroxide. Many of you learned this before. Aluminum oxide, which is the amphoteric oxide, can react with the hot and concentrated sodium hydroxide with water, form this sodium tetrahydroxoaluminate. Okay, this is what you learn in the syllabus. Now is asking the aluminum hydroxide with sodium hydroxide, not oxide. So if you can recall what you learned in the paper 3, the qualitative test. So when we add a few drops of the sodium hydroxide solution with this aluminum solution, it will form white precipitate. So the white precipitate is the aluminum hydroxide. And when we add in excess, the sodium hydroxide will further react with the aluminum hydroxide, form a compound. And this compound, it can dissolve or is soluble in the solution or water. So, and the compound that form is a sodium tetrahydroxoaluminate. So, which is clear. So, what you need to give is, of course, this equation. You just need to remember, aluminum hydroxide is amphoteric, as is mentioned, and it can react with the sodium hydroxide and is formed the same compound as you learn in the syllabus, sodium tetrahydroxoaluminate. So you just need to put this compound, and that's the equation. Okay, I hope you understand what I say. Right, that's all. Thank you.